All right, so 2.3, linear inequalities. So we have linear inequalities. So understand basic terminology related to inequalities. So know what the symbols are, what they mean, what they look like, how it's affected graphically. Recalling some of our inequality rules. If you have y is less than x minus 3, that means that you're shading below the line, right? Below the boundary line. And your boundary line is dashed. And that's because it's less than, right? If you have y is less than or equal to, you're still shading, but what changes about your boundary line? It's a solid boundary line. Do you remember that? Okay. If you're greater than, you're shaded above the boundary line. And your line is dashed. And if you're greater than or equal to, you're shaded below, grade above with a solid. So these are your dashed lines. And these are your solid lines. These are below. This row is above, below, and this row is above. Think about it. Okay. Does that all ring bells? Remember that? Okay, cool. All right, here we go. So when you are solving inequalities, you're still following the same process. You have to get the x by itself in order to solve the inequality. So our job is to get x by itself. So this one, before we do anything, we have to get rid of the fraction so that we can then work in the numerator, right? Can't just jump into the numerator, got to get there. So how do I get rid of the -4? I'm going to multiply. I'm going to multiply both sides by -4. So multiplying both sides by -4 is the first thing I did. So after I do that, I'm left with negative. I'm going to distribute that. Oh, ooh, ooh. The pen did that. Distribute. That gives me -8x minus 4 is less than 2 minus x. Okay, the second thing I need to do, when you're working with inequalities, it's best to try to, you read books from left to right. So you want to read your inequalities from left to right. Does that make sense? Mm-hmm. So you want to get your x values to the left and your non-x values to the right. So I'm going to add 4. And I'm going to add x to both sides. I like to do it at one step. Do you have to do it in one step? No. No, but at this point in my life, I preferred one step. So I have -8x and +1x makes -7x. I have 2 and 4, which makes 6. Now this is a key part here. When after you've moved, you're now down to dividing. If you divide or multiply a negative, it's going to change the signs. Negative changes signs. So I'm dividing by -7, which means that instead of this being a less than, it's going to become a greater than. So this leads to x is greater than -6/7. Since this is a single variable inequality, when you're graphing this, it's just on a number line. Here's 0, here's 1, here's -1, sorry. Here's -6/7. And x is greater than -6/7. So that means that it's an open circle heading to the right. Okay, I can't remember if this is the book that instead of open circles, they use parentheses, but yes. If it's a closed circle, it uses a bracket, I think, on your My Math Lab. Can't remember. I think this is the book that does that. but open circle is a parenthesis, a closed circle is a bracket. Either way, greater than is to the right, less than is to the left. L's with L's. Okay. I would like you to take a moment and solve this inequality. Okay, so the first thing you should have did, because there's a variable on both sides, is to distribute. Was that the first thing y'all did?
Yes.
So after you distribute, you have -4 plus 6x is greater than or equal to 8 minus 2x plus 4.
Yes.
And then we're going to combine like terms. So I'm going to be +4 plus 4 plus 2x plus 2x. So now I'm left with 8x is greater than or equal to, and I have 8 plus 4 is 12 plus 4 is 16. And then my last step is to divide. So I divide by 8, it's positive, so it doesn't affect my sign. So I'm left with x is greater than or equal to 2. And the solution would be graphed on a number line. No, I'm just making sure you know what, if you had to. And it would be greater than or equal to, so it's solid or a bracket, and it goes forever to the right. Right. Yep, that's your right. As you point with your right hand. Yes. So again, if it's open, it's parentheses. If it's closed, it is a bracket. All right, questions, comments, concerns? Cool. All right, now we're gonna talk about graphing them. So how do you graph an inequality in the calculator? Well, I'm glad you asked. Okay, so when graphing an inequality in the calculator, I have x plus 3 is greater than or equal to 2x. So you're gonna graph them each in the calculator, and then you're looking for is less than, I'm sorry, I said greater than, less than, equal to. Okay, so you're looking for one, where do they intersect? That's the first thing you're looking for. And two, then if I'm looking for less than, so I need x plus 3 to be less than 2x, I'm looking for when it's x plus 3 below 2x. Okay, so I'm going to go to my handy dandy calculadora. Open her up. Turn her on. And I'm going to put in my y1, which is x. Oh, that's not even the y's. Let's try that again. X plus 3. Put in my y2, which is 2x. Are you with me?
No, give me a second.
And then I'm going to hit graph. The first thing it says I need to find is their intersection, right? So I'm going to find where they intersect. So second, trace, intersect. And they intersect at 3. Okay. Okay, so now I have it in, and I'm looking for, it says x plus 3 is less than or equal to 2x. I'm looking for when is x plus 3 below 2x. So x plus 3 is my, which line am I on? Trace. So x plus 3 is this line, the one on top, and I want it to be below 2x. So at what point is it below 2x? Well, that's when not when I'm less than 3, but when I am greater than 3. So notice as I move my little spider, that's when x plus 3 is below 2x. It's when X is greater than 3. The other way to look at it is from the table. If I go to the table, I'm looking for when it 2x, which is my y2, when are its values greater than x3, x plus 3, my y1. So looking here, my values for y2 are greater after 3. Do you see that? After 3, y2 is greater than y1. At 3, they're equal, right? So either it's going to go to the left or to the right. When I go less than, y2 is less than. When I go greater than 3, that's when it's true. So my answer is when x is greater than or equal to 3. So you can analyze it from the table, or you can analyze it from the graph. On the table, you're actually looking and comparing the values. From the graph, you're looking, you hit trace and you're looking at the location of when is x plus 3 physically below 2x, and it's physically below it after 3. So after x equals 3 is when it's physically below it. Okay. And that is how that works graphically. So this is going to be our stopping point for today. Tomorrow we will finish inequalities, and yeah.